take a look at this next round. This next round's a little bit different because the difference is that there's arrows on the ends of the graphs. And so, in our last, on the page before, right, there was just like a dot. And we said, oh, okay, well the graph ends here, and we drew a line right there. So here, there's no dot. And so, that makes this graph way different, right? That means this graph actually continues forever and ever and ever. It goes up and a little bit to the right forever, right? So it goes up forever, and even though it looks like it's only going a little bit to the right, if it goes on forever and ever and ever, in fact, it will continue and continue and continue and continue to the right, and so it's going up forever, and it's also going to the right forever. So remember when we tried to draw a box around the function, we can't draw a box around this one, right? It just continues forever and continues forever. And over here, it goes down forever, and it's going a little bit to the left at a time, and so it's also going to go left forever. So when I go to try to draw the box, right, it's like I can't even draw it here or way out to the left or over here because the graph literally continues forever, and so there is no box. And so the domain of this graph, all the possible x values, continue all the way from forever to the left to forever to the right. And the way we write that is we just say the domain is all real numbers. And we use the word real. We haven't talked about imaginary numbers yet, so don't worry about it. But we just say all real numbers. And for the range, the y value can be anything all the way from the bottom of forever to the top of forever, right? We can use the word infinity, from negative infinity to positive infinity. But regardless, what that's saying is that it can be anything. The y value can be absolutely anything. Okay, so this is a very different kind of graph. Now, it seems like, okay, well, cool, graphs that have arrows just have all real numbers, then we're done. But actually, that's not the case. Let's look at the next one. This one, let's see where the arrows are. The arrows, they point up. This arrow points up, and it goes up forever. But it's also going a little bit again off to this side, to the right, so we actually have to acknowledge this one goes to the right forever as well. This arrow, it goes up forever, and it's going a little bit off to the left, and it'll just keep going and going and going a little bit at a time, but it'll go off to the left forever. And so when I go to look at the domain, I'm looking for the right to the left. Well, I can't draw a line, right? There's no limit on the left. There's no stopping point on the left. And the same on the right, there's no stopping point. So the domain is still all real numbers. But the difference is with the range, because the range talks about up and down. Now it goes up forever, right? There's no stopping point here. It just keeps going up and up and up. But there is a stopping point here. It does not go below this line. So how can we write something that says y can be anything, 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 as long as it's above this line? How can we say that? Well, what y value is that? That's a y value of 0. So what we want to say is that y, what do we know about y? Well, it can be equal to 0, or it can be anything that's above 0, anything that is greater than 0. Okay? That is our range. Y is anything greater than 0. It can be 0.001, it can be 2, it can be 10 million, but what it can't be is negative 2, right? That's not part of the graph, so it has to be greater than or equal to 0. How about this one? Let's talk about the limits here. We're going to start with the domain. Here, it actually, this graph stops here. It doesn't go past that on the right, right? This is the wall on the right. But then it does go on forever and ever and ever and ever to the left. So how do we say, here's the x value is 4 here. How do we say x can be 4, right here it's 4, it's equal to 4. Or it can be anything to the left of 4. It can't be anything to the right, it can't be 5. But it can be 3, 2, or 1.5, negative 4.3, right? It can be any of those things all the way to negative 10 billion gazillion infinity. So we can say it can be equal to 4, but then it can also be less than 4, right? X can be any value less than 4. How about the y value? Let's see if there's a limit. Let's see, this arrow, it goes to the left forever, but it's also going a little bit up, right? So this arrow also goes up forever, but it doesn't continue down forever, right? Here, we have this line, and the graph does not go below this line. So, what does that tell us? It's kind of similar to the last graph, right, where this is the y value of 0. Y can be equal to 0, or it can be any value that's more than, any value that's above 0, greater than 0. Okay, go ahead and try the 6 problems below, these 6.